In our previous video, we took an overview look at everything that we need to do to gather GPS data by using live data and observables. In this video, we're going to do a hands-on implementation. We'll start with the smallest changes, so Android manifest permissions and our build.gradle libraries. From there, we're going to create this DTO that contains the location data that we want to use. We're going to create the Android view model, and that will be fairly lightweight, but the live data, the location live data class that is attached to this Android view model is going to be where most of our work is. And inside of that, we're going to create this location request object, which is essentially a filter that says how frequently we want to receive updates. So without further ado, let's jump right in. In our previous video, I merged in the branch that we were working on, so I have just pulled an updated master and I've changed to master. Let's go ahead and create a new branch for GPS, and we'll just call this GPS. Now we have our GPS branch, so double shift build.gradle, and we want the one that's inside of the app module where we can place dependencies. Now I'm going to paste in the location services library that I'm using that is the most recent as of the time of this recording. But I'll tell you that these change very frequently, so you're welcome to see mine on GitHub, but also just do a quick search and see if there's a newer one that you might want to use instead. So we start with that, we tell it to go ahead and rebuild, and while it's rebuilding, we're going to go to our Android manifest, and we need to add a couple of more permissions. So we have internet already, camera, and write external storage. Let's add access find location and access course location, just like so. Now, these are what we call dangerous permissions, so we have to add them here, but we also have to prompt for them at time of need. These days, a lot of users are conscious about apps that might be tracking their position, so that's why we want to prompt at time of need. So we go ahead and save that. Now, the next thing that we want to create is a little DTO that will just hold some basic information for us about the location. So we'll navigate down. We already have a DTO directory. Right-click New. We'll do Kotlin, and we'll make this one a class. And we'll call this one Location Details. Inside of Location Details, we're going to add the word data to indicate that this is a data class, and then we'll make a one-line DTO. So we'll say val longitude string and val latitude string. Why string? This is a matter of a little bit of debate because oftentimes we'll receive this data in the form of a double. The trick with a double is that there's floating point arithmetic, which, think about 1 divided by 3. That's 0.3 continuous, but a computer can't really represent 0.3 continuous. It has finite memory, so at some point it just truncates everything after the last 3. So kind of think of it in those words. Basically, you end up with a little bit of inaccuracy as you get further to the right of a decimal point, which oftentimes doesn't matter. But if you're looking at GPS, those points to the right of a decimal point often are important. So my personal preference is to convert this to a string as soon as possible. You could also use something like a big decimal, or if you prefer, keep it in its native double form. The time I found that to be interesting is when I was actually uploading data to a database. I found that using a double, uploading it, added a bit more inaccuracy, so just something to keep in mind. Nonetheless, that's all we need to do for our location details. Now, we need to create a view model as well, and our previous view model is right here under our main fragment. We could typically just bolt more onto this view model, but we need to create a new view model because you notice that this view model that we already have is just a plain old object. It's not really doing anything special with the Android operating system itself. For GPS, we do need a view model that knows a bit more about the Android operating system, so we have to change the inheritance hierarchy. Instead of extending from view model, we have to extend from Android view model. So we'll just call this one location view model. I might want to change that to something more generic in the future because I might find other uses for this view model, but nonetheless, this will work for the moment. And then we'll say colon to indicate extension. Following the colon, we'll say Android view model. One trick is that the Android view model has a constructor that takes a parameter, and that parameter is application. Now, we're going to receive that as a constructor call to us. So what we need to do is add a parameter here, which is application application. Variable name is application and variable type is application. So Alt-Enter, import that, and if you can kind of visualize this, we're going to construct a location view model. We're going to pass in an application object, and we're simply making a super call and essentially taking this application object and passing it up to the superclass so that we can initialize that superclass with our application object. I know we've looked at several files. Let's just take a quick check of where we are. We've added the build Gradle libraries. We've updated the Android manifest. Right now we're creating the Android view model. And we are creating this attribute right here of live data that's referencing this location live data class. Now, one note, we have not yet created this location live data class. So I'm going to go ahead and make it an attribute of the Android view model. And I know it's going to redline immediately until I make that location live data class. But don't worry, that comes next. And then the location request object is part of that. The bulk of the work is here. But once we wrap up with that, we should be in good shape. So let's make that attribute of location view model. So inside of here, we'll say private val location live data equals location live data, and then we're going to need to pass to this that application parameter that was passed into us through the constructor. As I promised, location live data currently is redlining. We'll fix that when we create the class. Now you notice also we've given this private access. So we want to expose this through a getter method, or getter function rather, in Kotlin. And we know there's a little shortcut in Kotlin to do this. We can say fun get location live data, in parentheses to indicate it's a function. Normally we'd think open curly, close curly, and the like, but in Kotlin we can just say equals and then location live data, just like so, and that becomes a shortcut. So at this point, our view model is actually complete. Let's go ahead and go back to our project. Under UI main, let's make our live data class. So we'll say Kotlin class, and we need to fill in this red line here, so let's make it called location live data, just like so. Now location live data is going to be an extension of live data, and we need to tell it what it's holding that it's going to expose to the outside world. Well, guess what? Remember that little location details class we made just a moment ago with our strings for latitude and longitude? That is what we're going to expose. So let's say location details is the generic type for that live data. And just do a little bit of import here. And fix our constructor call right there, and we're in good shape. Now that we have the structure of this class, let's go ahead and create the location request object. We only need one location request object because we only need to state this information one time. So if you think in the language of Java, you might think of a static attribute or maybe a singleton design pattern. Those concepts in the Kotlin programming language are implemented with something called a companion object. So we create this with just companion object, just like so, open curly, close curly. There's a lot you can do within this open curly, close curly, but you can only have one of these companion object structures within a single class. So let's declare a variable. We'll say val location request colon location request, so of type location request, equals, and red lines make me nervous, so before we get too far, let's go ahead and import that. If your import doesn't work, it's probably because you don't have the library in build.gradle that we did initially, or you didn't do a sync. So just double check that. But nonetheless, variable location request of type location request, and then we're going to say equals location request.create. So that is a factory method that essentially is creating a location request object. In the land of Java, we'd often be tempted to say location request and then start calling methods on it. But let's remember this is Kotlin, and there's a little more efficient way to do it, and that is with our scoped functions. So remember that a scope function is going to be applied to an object, and everything within the scope of that function, in other words, the open curly, close curly, will be applied on that object. In our case, we're going to use apply, where we can refer to the object through the this operator, and when this scope function is all finished, it's going to return the object that we're working on. So after create.apply, and then open and close curly to give us that scope, and inside of this, we'll say interval equals 60,000, so intervals in milliseconds, and remember that says how quickly am I going to ask for GPS data. we'll say fastest interval. That means how often am I willing to get GPS data for free? So we can piggyback off of other apps that are asking for data, and we can receive location updates from them, and we get that at no cost essentially, where the interval says we're going to proactively ask for location updates at this interval. In other words, fastest interval will almost always be a fraction of interval. It will almost always be smaller. So I don't like magic numbers. Let's go ahead and make a constant out of this. Let's say val 1 minute equals 60,000, and then interval will say 1 minute. And fastest interval will say 1 minute divided by 4. So maybe what we mean there is we'll ask for GPS every minute, but gosh, within that, if we can get it free 4 times, or maybe every 15 seconds or so, sure, that's fine. Now, one tricky thing here is it gives us a type mismatch, which is a bit weird just because we converted this number to a constant. So we do need to specify the type. After we declare the constant, let's just say a type of long, like so, and then the red lines go away. Okay, one more thing that we want to set here is the priority. The priority means, are we more interested in location accuracy or battery efficiency? So priority will say location request dot, and then take a look. You see we have a few options. We have high accuracy, we have balanced power, we have low power, and we have no power. So no power means I'm only going to get free GPS from other apps. Low power means I just need to know roughly where I am. Where high power, or high accuracy rather, means I'm willing to spend the energy to get a very accurate location. Because we're dealing with plant specimens here in this application, we could have multiple specimens at one address. So we need something that's very finite, so I'm going to go ahead and say high accuracy. Now we know the way that live data works. When the live data changes, anybody who is looking at the live data, or watching or observing if you prefer, will see that the live data has changed. If someone stops looking at the live data, perhaps it goes to a stop state or a destroyed state or something like that, it's no longer looking. Now there's a handy function that we have on live data, and it simply tells us if someone has started looking or nobody is looking. We can use that very valuable function to tell us that we want to subscribe to GPS when at least one person is looking at us, or if you prefer, one activity, one fragment, and then unsubscribe from GPS when nobody's looking. This is incredibly powerful because in the old days when we had to use the Android lifecycle methods, we often had to put a lot of redundant code in a lot of redundant places. And at the same note, the bigger risk was we would forget, and we would end up in a scenario where we would subscribe to location updates, and we would continue to get location updates even after the app has closed. So, the functions we need, one is on active, and you notice that that comes up and it gives us an override here. So this means that somebody has started to watch the data. The other one that we need is on inactive. What that means is nobody's watching the data anymore. So for on active, we want to say, okay, I'm interested in listening to location updates. So let's make a function for this. Let's say start location updates. Let's let Android Studio create this function for us. Now inside of this function, we are going to use something called a fused location client. We're going to need this in several places, so let's go ahead and declare it at the top. We'll say private var fused location client equals location services dot get fused location provider client, and we're going to pass in context, just like so. Now to pass in the context, we need to receive the context in our location live data constructor. We can either pass in application or context. Well, okay, let's run back to our location view model and let's see what we're passing in. Well, it looks like we're passing in application here. If we take a look at context, we see that it is a superclass, and way down here we have application as an indirect subclass. So while it really could be either, since the object type is application, it could be application or it could be held in the super type of context. I have found that context works better. So let's say context, context, just like so. Now this is Brandon talking to you from the future. One thing I like about recorded lectures like this is I can go back and I can fix my mistakes. At the end of this video, we do get the whole demonstration to work. And this is one thing I did have to edit because I initially chose application, then remembered it didn't work, and I had to go back and change it to context. I came back to this point in the video and simply edited that back in so that it wouldn't be confusing that you'd see me do it one way and then go back and change it. I just want to forewarn you, when you see the demo continue from here for the next few minutes, if you look very closely, you'll see that I actually had application in there. Ignore that, just pretend it says context. Go back to location view model, and you notice that this now compiles because we've satisfied this thing that used to redline. So fused location client, what does that do for us? It assembles a few different things. It assembles a location request, which is this kind of filter companion object that we put together earlier. And it also fuses together a location callback. Now, callback is important. If you think about a callback, it's something like our onActivityResult function we saw earlier, where we toggle the camera through an implicit intent, and then we hear back from that in onActivityResult, similar to the self-addressed stamped envelope analogy that I gave earlier. So let's go to the start location updates, and we don't have everything we need just yet, but we can start to fill in some blanks. So we'll say fused location client dot request location updates, and then we pass in our location request, and then we need a location callback, which is what we don't have yet, so we'll just go ahead and start that. Looper don't need to worry about, simply pass in null, and we're fine. Okay, location callback we need to create, so let's go ahead and create that. And this is kind of similar to that concept of a static function that we talked about earlier. What we'll do is we'll say private val location callback equals object colon object of type location callback. So we are essentially making an inline class here that's going to handle callbacks. We're assigning it to this variable location callback, and we're passing that variable right up here in start location updates and the request location updates function. Now, you notice I'm putting it down here on line 27. Order isn't really important given the way we're doing it. I could put it at the top, I could put it at the bottom, but if you're wondering, does it need to be above the method where it's used? No, not necessarily. It just needs to be declared somewhere. So location callback gives us a function called onLocationResult, and what that means is we have heard a location from the Android device. What do we want to do with it? Well, let's tidy up these names a little bit. So we'll say location result colon location result, and then we'll pass in that location result to the callback. I'm sorry, to the super function right there. Now, here's a little trick with Kotlin. One thing people like about Kotlin is the way that it handles nulls. In other words, you're less likely to get a null pointer exception. If you call a function on a null object in Kotlin, it simply returns null. In Java, if you call a method on a variable that does not contain an object, in other words, it's null, it would throw a null pointer exception. One other handy thing that Kotlin gives us is this Elvis operator, which means if the thing to my left is null, substitute it with the thing to my right. We can get a little tricky here. We can say location result, and then the Elvis operator is question mark colon. And what that means is if location result is null, then do this. What is this? Return. We have nothing to do. If it's null, forget it. So it's not as obvious as it would be in Java where you would actually say equal null or not equal null, but that's what this line is doing in just a few words. Let's say that we actually did get a result. If we did get a result, it's not going to return, and the line where my cursor is now is going to execute. So I'll go ahead and say for, let's say location in location result dot locations. It could be plural locations, not likely given our use case. Now, within this, I've received a location object, and what do I want to do with it? Well, I want to change my live data. I want to make a note that the live data is changing. And so let's call a setter method. Let's call set location data and pass in this location. And we'll just use the setter method to essentially modify our live data. Okay, we'll put it in the enclosing class just like so. If we've received a location update, this function will be called. Okay, and we could put some other things like what the callback is, so on and so forth. Now, we have our location update. How do we update this location details, which is the subject of our live data? That's a little bit tricky. Normally, if we were on the view model, we would do something. If we were in another class, we could do something like location live data dot set value. And that's saying, okay, I want to modify the data that's here. I'm going to invoke this set value function. That's how we would do it if we were outside of the class. Inside of the class, though, we can simply say set value. And notice what the set value is accepting. It's accepting an object of type location details. What's location details? Well, take a look at our generic identifier here on our live data. It is the subject of the live data. In other words, it's the thing that our observers are going to watch. So we could do set value, but we know there's a shortcut in Kotlin as well. We can just say value equals, and that essentially invokes that setter method. Now, value equals, well, gosh, we're going to have to pass it a location details object. And that's different from the location object that we've received because location details is a type that we have created. Remember this thing we created about 20 minutes ago where we had 2 strings passed in. So we have to do a little conversion here from the location that we were passed to a new location details object. That's not nearly as hard as I'm making it sound because all we have to do is construct a location details object. So location details, and then you notice that it needs to take a longitude as a string and a latitude as a string. So we say location dot longitude dot toString, and then we say location dot latitude dot toString, just like so. And it doesn't like my location. It looks like it wants me to do a not null. I'm comfortable. Well, I'll tell you what. Could we just take away the nullability? Yeah, we can. We take away the nullability operator there. And just double checking, because we've checked for null here, we can safely assume that we have a location here. Not to mention it's in a loop, so good chance it is going to be a not null object. So I'm comfortable with our nullability here. We're getting in the home stretch of this class. So we have our on active, and one other thing that we're going to want to do in the on active is let's see if we can go ahead and give the user some kind of information, even if it might be slightly old information. So what we can do is we can say fused location client dot last location. Just say, hey, what's the last location that you gave to me? And then we'll say dot add on success listener. And then within this, you see it gives us several options. We essentially want to do a little bit of lambda action. We're going to be receiving a location object here. So let's start with location of type location. And again, location provided to us in that library we imported. It simply has latitude, longitude, and a few other details. So location is of type location, and then we say that goes into location.also. Remember, also is another one of our scoped functions, very important in the land of Kotlin. Also slightly different from apply in just one way, and that is the object that it's operating on. We've referred to it with it instead of this. If you prefer this, have at it. The only difference is that you have to say explicitly this is optional. You can either indicate it, or if you don't indicate it, the scope function will assume that it's operating on the object that it's operating on. I like also here because all we're going to do is invoke that function that we just created, the one called setLocationData, and we know we have to pass a location in. Well, guess what? Because since it's the also scope function, that's simply represented by our it variable, and you see, sure enough, that is a variable of type location, and we're all good. One more thing to go then in this class on the on and active. We need to turn off location updates. So we'll simply say fused location client and then remove location updates, and we have to tell it which callback, so we'll say location callback. So disconnect, unsubscribe. Thank you. Now finally we're able to go back to our main fragment. We have a bit of work to do here as well. So let's take a look at the onActivity created function, and let's add a new call here, prep request location updates. I say prep because I know we're going to need to do permissions here, so we're going to need to check for permissions first. I covered permissions in a previous video, so I'll hit that a little bit and fast forward just for the length of this video. So first of all, we'll say if context compat dot check self permission. So do I already have this permission? We start with the context object. We'll assert that it's not null, and then we're going to say manifest dot permission dot access find location, and then equal package manager dot permission granted. So do we already have this permission is the question. Open curly, close curly. If we do, we'll request location updates. It's a function we've not made yet. There we go. So make it like so. If not, we need to request permission. So we'll say val permission request equals array of manifest dot permission dot guess what? Access find location one more time. You might recall that the permission request should be an array of strings. Here we have only one string, but we still need to wrap it into an array because that's what the function signature is expecting. What function? Request permissions. So we're passing this object of the permissions that we want to request to the request permissions function, permission request. And then we will make a location request code. Let's see, what number can we use? We'll use 2000. We'll say, I'll make this one private while we're up here. So we'll say private val location permission request code equals, we haven't used 2000 yet, so we'll go ahead and use 2000 just like so. So we'll copy that value and we will simply paste it right down here in this location request code. And at this point I think we're in good shape. Okay, now we need to go update our on request permission result, and you see that we already started doing that when we invoked the camera in this previous series of videos. We kind of had a hunch that we were going to have more permissions, so I set up a when statement like so, which is kind of like a case switch statement or switch case statement in other languages like Java. So we're saying take this request code and that we're receiving back. This is a callback. So the user at this point has either chosen accept or decline the permissions. And now we're hearing back after the user has made that selection. So when the request code is equal to camera permission request, we do this behavior. But now let's add basically another stanza. We'll say when it's equal to location permission request code, then we use the arrow operator, the same one you see in lambdas. Here we're just using it as this switch case or this when syntax, which is perfectly valid. So when we've heard back from this, we'll say open curly and close curly, make a block, and then we'll say if grant results, and you can see what we're doing on line 106, we're applying the same thing down here, is not empty. And grant results, because we only have one, we just need to look at that very first element, equal package manager dot permission granted. Then we say open curly, and guess what? We go back to that request location updates function that we made just a few moments ago. Otherwise, let's inform the user. And again, I'll just borrow, I probably could have copied and pasted a lot of that and just borrowed the syntax, but we'll say unable to update location without permission. Okay, now, whether the user has granted us permission previously or just granted us permission, we're finally at the point where we can request location updates. So we created that function earlier. We let Android Studio create the function for us. Now we simply need to fill in some details. First, we need to get access to the view model that we created. So let's say view model providers dot of this dot get location view model class dot java. If that syntax feels a little bit funny, just take a look up above where the Android system brought in our view model when it initially created this project. Looks very similar. As a matter of fact, you see we need to assign it to a variable that we'll be able to use later. So I'll go ahead and declare that variable up here. We'll say location view model and change this to location view model, just like so. Okay, and back down to our function that we were working on. So now we have brought in this view model. We'll save it to this location view model late init variable that I've just declared. Now after that, the reason we pull that in is we want to observe on this. So we're going to say location view model dot get location live data, remember who that is, and then we're going to say dot observe. Within the observe function call, we'll start with this, and then we'll create an inline observer, just like so. Now, within that inline observer, the item that we're observing on, which is this location live data, is kind of put into our friendly it variable because it's only one parameter that's getting passed in. So if we take a look at it, we can say it dot, oh, look at that, it dot latitude, and we can say it dot longitude. Very cool. If we take a look at our layout, we know we have this thing LBL latitude value, which is where the latitude should go. And then I look at the other component, and I know it's a little tricky here to see on the screen. Looks like I didn't rename that to something logical. So let me go ahead and rename this other component to LBL longitude value, just like so, and then save. We'll go back to our fragment now, and you see what we can do is we can refer to those components and we can update them with our latitude and longitude. So let's say LBL latitude value equals IT latitude, and then LBL latitude value dot text, because we're actually changing the text attribute on that component, not setting the whole component, but just updating the text that's within the component. Do the same thing to LBL longitude value dot text equals it.longitude. Now I've started the application in debug mode. I went ahead and accepted location permission. Right now I have the location set to Nook, Greenland. So if you take a look, hit the little ellipsis down here, location. I can put in Nook, Greenland. Like Nook, hit set location because that's a very distinguishable location. Latitude of 64 is extraordinarily high. Longitude of -51, that can only be Nook. So you notice that I paused the video when I did that, so you see it updated while I had the video paused. Let's go ahead and change this to Cincinnati. Okay, 609 Walnut Street, that's pretty close, 39.1031 and -84.51. If you're from Cincinnati, that -84.51 might actually ring a bell. You notice I said it and it didn't take too long before it updated over here. If we were to change it to, say, Denver, once again, Denver, set location, and in just a few moments it will update over here again, depending on where we are within that 1 minute cycle. So that's a way that we can do some updates here. That's a way that we can get our location data through live data, and we can use live data's onActivate and onInActivate to subscribe and unsubscribe, and therefore we don't have to mess around with all of the old Android lifecycle stuff. I know this is quite a long video, but nonetheless I wanted to get through it all in one thought, all in one kind of cohesive idea. So I sure hope this video has been worth your time, and I look forward to reading your comments. Thank you.